parallelogram, so which was what? Base times height. So they may have a proof that talks about the area of a triangle, which we all know is what? Half the base times the height. And their proof of it is to take any, well, I don't want to do that. Take a triangle and what? Dice it up. So in other words, to find the area of this thing, they may, for their proof of it, take this piece, cut it off, and then what? Remove it over to another spot to make a parallelogram. That's not working out too well. Why is that not working out too well? Maybe I can cut it off the way I want to cut it off. There it is. Maybe that's that. So I still don't like the way I have that.
I might have to hold it like that.
They're a little picky on the proof per se. But let's say I wanted to find the area of that. Now I could take that, slice it up, and reform a parallelogram. So if I took this piece and then moved it over to here, either way I can take this. That's not the way I really want to do it. I'll just show you the way they're going to do it. They're going to take this triangle and they're going to double it, right? And they're going to reform it to this figure. So basically they took the same triangle and they just simply doubled it. You're like, well, why would you do that? You're only asked to find the area of a parallelogram. Why are you every triangle, why are you doubling it? Well, it's because the proof of it would be if I took that triangle, and we're supposed to be finding the area of this black triangle, and I doubled it, I now form a parallelogram, which is base times height, and obviously then I can see that, well, I don't really want the area of that entire parallelogram, and that's why we take what? Half of it. Okay, half of it. I mean, it was easier when you looked at, let's say, a right triangle that was, let's say, 4 by 12. A game plan to find the area of that triangle was to what? Double it and go what? 4 times 12? But just remembering that, well, you weren't asked to find the area of both of these things. You were just asked to find the area of the triangle, so you take that and divide by what? 2. So it was the proof of the triangle, which I totally botched on. There's another way to do it too. There's another way to do it too. And I just took it, doubled it, did that. And the same thing with the trapezoid. We need to know that they could have a proof. We all know the formula. The formula is 1/2 what? B1 plus B2 times height. And again, you want to memorize this. The proof of it is to do the same thing what I did with the triangle. And again, there's another proof on top of that, but we can't have too many. And they just simply take that trapezoid and they double it. And what? Form it into a parallelogram. Now understand, what's the entire length all the way across? It's not just base 1 or base 2. It's base 2 plus what? Base 1. So it's these guys combined, again, times the height. So in a normal parallelogram, that's what I would do. I would take B2 plus B1, which is the entire base, times the height. But remembering, what am I doing here? I'm just finding the area of a trapezoid. The proof of the formula is to do this kind of mechanism, double it, and just remember to take half of it. Okay, that's all it's really saying. All right, what's the area of a regular polygon? This is your memorization. 1/2. Rusty. All right, let's look at all the parts of a polygon. We have a what? Apothem, which is what? From the center to the midpoint. I could have such a thing as a radius. A radius goes from the center to the very edge of the hexagon, octagon, whatever. Because it's like I have an imaginary belief that what? There's a circle that goes around it. So it's like the radius of a circle that could go around it, but nevertheless, you got your apothem, you got your radius. Yes, we're going to have to know the perimeter. And that's what? Adding up all the sides. Now, if I forget my formula, I could always bank on what? Triangles. Good. You can break this thing into triangles and then just simply say, how many of those triangles do I got? All right, how many do I got? Morning. All right, area of a circle. What's the formula for area of a circle? There's plenty of desks over here. Come on over. I got lots of room over here today. Area of a what? Circle is pi r squared, right? And that's the area of all the space inside. Versus circumference. What's circumference?
2 pi r.
2 pi r. Now, will they have some type of problems where they may have a modification of that and talk about the thing in terms of the diameter? Yes. Just understand that how many radiuses does it take to make the diameter? 2. So just be careful there. Don't let them confuse you and say, oh, could you just take pi diameter squared or something like that? Or, no. Okay, no. The diameter is basically 2 radiuses put together. And of course, this test, as I've said in class, it's all about a modification to find sectors or arc length, whatever it may be. So again, we're going to be modifying this formula because I don't want the entire length of the arc, or circumference, I just want the length of the arc. And so I did say in class, I'm really thinking that, well, let's do those. To find the arc length, that you may want to think about like a formula. It's a piece of what? 2 pi r? And that piece is always x of 360, unless it's in radians, which we're going to talk about in a second. So knowing this formula is not a bad idea. And then what? The area of a sector, a little bit of a difference. I want the area of that. Again, it's a piece of pi r squared, so to get the sector, and that's what it's called, you could use the formula, which is what? X of 360 times pi r squared. So it's a piece of that. Okay, so I don't know. I think that maybe you should think about putting that formula down. All right, let's talk about some ones. Again, there's lots of sectors on the test. So circle W, this came off their released items. These are former test questions on the FSA. Circle W is shown with the shaded sector. The angle is 120. The area of the shaded sector is 28 pi inches. What's the circumference? And you're like, what? So they gave me this, right? And they said that that is 27 pi. Now, if this is 120 degrees, what is this basically? This is how much of the pizza?
1/3.
Good. It's 1/3 of the area. So what's the whole area?
360.
Right? So if that's 1/3 of it, then the entire area should be what? 27 times 3, which the entire area should be 81 pi. True? Yeah, but how's that going to help you get circumference? Well, with this formula, can I find the radius? Yeah. How do I find area? Pi r squared. And when I divide by, right, I'm trying to find the radius. The pi's go bye-bye. So the radius squared is 9. So what's the radius? 3. Right? Take the square root of it. So the radius is 3. What did I do?
You said the radius squared is 9, but the radius itself is 9.
Oh, 81. Yeah, okay. No, there you go. Thank you. All right, so the radius, this is 81. Good call. That's why you guys paused. I was wondering, what did I just do? Why did you guys just pause? All right, so the radius is 9. You're like, man, I'm doing all this work just to find the circumference? Yeah, that's fun. So what is it? 2 pi r is the circumference. And now that you know the radius, the circumference in terms of pi is what? B? 18 pi. So let's go back in there again. So they gave me the area of the sector, and I understood it's 1/3. So if it's 1/3, then basically the whole area is 81 pi. So what would the radius be? If the area is 81 pi, the radius would be 9. Now find the circumference. All right, what's the arc length MN of circle P with the inscribed angle MLK? I don't have my Microsoft Word at home. It doesn't let me do the equal sign. Like I guess it's my button or something. My kid must have done something. I don't know, video games or what have you. So I have no ability. So anyways, I want to find the arc length MN. MLK, well that's not MLK, let's say MLN. Yeah. MLN is 15 degrees. And the diameter is 20. So I wanted to mix it up. I wanted to kind of fuse topics. All right, so first things first, what am I supposed to be finding here? I'm supposed to be finding the length of the arc. But I never give you the inscribed angle, but you're not scared, right? If that's the inscribed angle, what's the actual angle? 30 degrees. So what is this arc length? Well, again, it's a piece of 2 pi r, because that's what arc length is. It's a piece of 2 pi r. In this case, what's x? It's 30 degrees. So that's 1/12 of 2 pi r, and the radius is 10. So basically, the arc length is 1/12 of 20 pi. You know, and you can simplify it, whatever, no big deal, right? So that's going to be, what, 5 pi over 3, if I leave it in terms of pi. So they gave it to you, though, with an inscribed angle, but there's nothing to worry about. If that's 15, then that's 30. And 30 is 1/12 of the circle. Okay, all right, here's one with radians. An artist is making a stained piece of glass of art. The stained piece is a sector with a circle of a radius of 3 and an arc measure of 3 pi over 4. So what is the exact area of that piece? So here's the dilemma that we got. Are we comfortable enough with radians to go get that area? I say no. Okay? I would say, you know what? Why don't you just use, because this is the length of the arc, use your radian formula, and I hope you got this down, right? This would be one of the first formulas I would write down. Radians is what? L over R. Okay, radians is L over R. Because I could find this angle. I could find that angle. All right, here we go. So what is this? The length of the arc, my fault, is 3 pi over 4. The radius is 3. That's enough to get the angle. Right? It's enough to get the angle. Now be careful with your fractions here. What's 3 pi over 3 divided by 3? It's the same as 3 pi over 4 times the reciprocal. Alright, if an irrigated section of land has a sprinkler that rotates through an angle of 144 degrees, we're going to go back to that problem I have everybody in here. Through 144 degrees, what's the area and the amount of land watered to reach the sprinkler of a maximum of 10 feet? So again, I've done this problem multiple ways. The angle that the sprinkler rotates, it only rotates, what, 144 degrees? So what's the amount of area that it waters? So I just got to say, this is a piece of 360, for sure, of not circumference this time, what is it? Pi r squared, so 144 of 360. Now, if they said to the nearest tenth, then they're okay probably with me substituting pi. And they'll probably go either way to tell you, I want to let pi be 3.14. But let's say we keep the fraction intact. When you simplify 140 over 360, it's 2/5. So 2/5 of the area, now the what? Diameter or radius? What was this? It reaches a maximum of 10 feet. So basically 10 feet that way, 10 feet that way, 10 feet that way. So that's pretty much saying what? The radius is 10. So it reaches a maximum spray distance of 10. So that would be the radius. That's code for radius. So what's the area of the sector that was watered? It's 2/5 of 100 pi. So it waters 40 pi, whatever, inches squared of area. Feet squared, my fault. So again, what did I do there? I just took the angle of that rotation, was 144 degrees. So that's 2/5. And again, if they said pi be 3.14, then you could just take 140 over 360 and call it a decimal, which would be 0.4. So if they didn't care, and you were going to plug in pi, then you could say, oh, I ain't worried about this then. 144 over 360 is 0.4. And it would be what? 0.4 times pi times the radius squared. If they said, just don't worry about it. All right, this is kind of silly, but apparently it's a standard. And you approximate the shape. Like, Colorado's not perfectly a rectangle, but they want me to treat it like a rectangle. Okay? Nevada is not quite a trapezoid, but it looks closest to a what? Trapezoid. Wyoming looks like a rectangle, and then Tennessee looks like a parallelogram. So they want me to approximate the areas using that to say which one has the biggest area, or which one of these states has an area of 288,602. Okay, so is that okay? It's kind of silly. It's not exact. An honors kid, that bothers an honors kid. An honors kid's like, it's not a parallelogram. It's kind of a parallelogram, but they're going to break up this thing into like the most perfect pieces. So you guys got to basically let your guard down, right? You honors kids got to let your guard down and say it's approximately a parallelogram, or it's approximately a trapezoid. So how would I find the area of that puppy? I would go just what? Base times height, so 445 times 604. His area is 268, so not it. Trapezoid. If I do a trapezoid, what's the formula? 1/2 B1, B2 times height. So what's B1? Looks like 334. The other base, 773. And the height's 491. You may want to just put 1/2 as what? 0.5. So does that sell the tickets, all right? 334 plus 773. You may need help. Did one person go up there?
Two.
Okay, good, because I don't think 16 pizzas are going to fit in that buggy. All right, okay, good. I'm just thinking that may not fly. All right, so that wouldn't work. That's 270, who cares? So anyways, I look and see which one would work. And again, a lot of kids are like, that ain't no parallelogram. Deal with it. Or maybe that, could that be more of a trapezoid? Yeah. Yeah, I don't know. I think I would call that more of a trapezoid. What do you guys think? Here's why.
I think it's a parallel.
Yeah, because look how off those are. 693 and 540, man. Those aren't equal, so that's pretty far, what? That's pretty far off. I probably would go with trapezoid. And then I would, again, see which one does that. All right? Just getting introduced to it. All right, 3D figures. So again, the formal jargon of it is what? Polyhedron. Polyhedron is just basically like a polygon, but it's hedron, so it's three-dimensional. There's solids where all the faces are polygons. So I've got like a triangular prism, is kind of a polyhedron. But even a pyramid's a polyhedron, as long as all the faces are polygons. Remember, polygons include triangles, rectangles, all that stuff. So all of these dudes are considered to be polyhedron. Now let's just talk about parts of it. So let me draw a bigger one. I don't think they'll get into some of this jargon, but they might. These are the base edges, right? That's a base edge. This is a base edge. These are more of a lateral edge. Remember, lateral means along the sides. Lateral is everything but the bases, right? So that's like a lateral edge, base edge. These are all, of course, what? Vertices. Okay, they're all just kind of vertices and stuff like that. So when I look at these things, again, understand the jargon. All right, we'll get going here in a sec. Polyhedron, again, a prism is a special polyhedron. A prism is a polyhedron where you've got two faces that are congruent and parallel. So just wheel to the back, I'm coming right there. So I could have a polyhedron on its side, right? I could have a polyhedron or a prism on its side. Again, it's the faces that are congruent and parallel. Just understand that the height is the distance between the bases. The height's the distance between the bases. So when we get into volume in a minute, remember, volume of a prism is what? Base times height? So what do I got to find first? I got to find the area of the triangle, either one of them, and then multiply by the height. So there's a lot of three-dimensional stuff on there, okay? So now, the unfortunate thing was if you had to find the area, the volume of a hexagonal prism, you'd have to find the area of the what? Regular hexagon, which is again what? 1/2 apothem times perimeter. And then multiply by the height, which again is the distance between the bases. But a polyhedron is generic. A polyhedron is just a 3D figure where all the faces are polygons. So let me ask you this. Is a cylinder a polyhedron?
No. Wait.
No, because not all the faces are polygons, right? Those are circles. A circle's not a polygon. So a cone would not be considered a polyhedron. I don't think they'll get into that kind of a vocab match with you. But just understand a polyhedron is not a cylinder, it's not a cone, it's not a sphere. It's anybody that has faces that are polygons, all right? And I'll finish with this. These are Plato's special Platonic solids. The tetrahedron is a what? Pyramid, basically. And all the faces are regular polygons. All the faces are regular polygons. So is an equilateral triangle a regular polygon?
Yes.
Yeah, because what's regular? Regular means all the sides are equal and all the angles are equal. So is a cube a polyhedron where all the faces are congruent polygons? Or they're all regular polygons? Yeah, because a square is the face. Is a square a regular polygon? Yeah. So you got the tetrahedron, the octahedron, which is basically just two pyramids connected. But all the faces, again, are what? Equilateral triangles. How many faces do you got? How many faces in an octahedron? 8. You got 4 on the top and then 4 on the bottom. A cube is a hexahedron. All the things are 6-sided. They're all squares. And then you got these weird ones. All right, we'll resume on the surface area here. Let me set up for this. Again, it's got a little bits of circumference in it because this thing, right, wraps. I kind of drew that the way I didn't want to draw it. But it wraps around the bottom of the cone. It's more like this. So if I take, we all see this part. What's that, pi r squared? And then this part, you're like, yeah, but what is that? It's not quite a rectangle. It's not quite something, but it's pi r l. And I need that slant height. But if you imagine I took it and I folded it up and it would wrap around what? It would wrap around the base of that. That's why it's got a little bit of pi r action in it, because what's circumference? 2 pi r? But it's not quite a full rectangle, this, that, and the other. Compared to who? The cylinder. The cylinder has this, right, as we remember. It's a full-blown pi r squared, and then this guy. Remember, the dimensions of this rectangle. The dimensions are, the length is what? Half of the circumference? Actually, no, it's all of it, isn't it? 2 pi r, because it wraps all the way around. And then this is the height of the cylinder. So that's why the formula is 2 pi r squared plus 2 pi r h. And again, that may be the person that you memorize right off the bat and you write it down. Alright, so there's your full-blown formula. The conage is what? Pi r squared plus pi r l. And then what's the surface area of a sphere? 4 pi r squareds. Okay, now I didn't talk about this, and I don't think they'll do it, but there's this thing called the great circle. The great circle. And what it is it's the biggest circle that you can draw around a ball. It's the same thing as the equator, right? The equator divides Earth into what, half? So it's the biggest circle that you could draw around a round object. If I had a tennis ball, I would draw on it. But it's a line that goes, and it would cut the sphere in half. So I don't think they'll ever mention it because, it's not really like a normal word. But it's the great circle. It's just like the equator. It's the biggest circle you could draw around it. Whatever. The formula is what? For a surface area, 4 pi r squared. So these are money. These are ones I got to make sure I've got it in my repertoire. And then there's modifications of it, right? Talking about like things that are rotated around an axis. Right? So we looked at a couple. We looked at like looking at a triangle. If I take a triangle and I spin it around an axis, what shape do we create? A cone. If I was asked to find the surface area of it, I really need the slant height, not this true height, right? I need to know what I need to get that done. So they'd have to give me, maybe if they gave me 1, 1, 1 negative, well, let's go bigger. And maybe, I went the wrong way, that's okay. So let's make it 1. So let's say I had that. So I'm going to take that triangle, I'm going to do what? I'm going to spin it around an axis to create a cone. How would I get that slant height? Does everybody see that that slant height would be the length of this line? And the length of that line would have to be done using what? Distance formula? But more than that, it doesn't have to be. Because what triangle do you see kind of right there? A right triangle. So what about good old Pythagoras? A squared plus b squared is c squared. So albeit that I could get the distance formula to find that length, I could also go, man, how far did you go up? Well, from 1 to 1, 1 to 4, that's a distance of what, 3? From negative 7, 1 to negative 1, 1, that's a distance of 6. So could I find the slant height like that? I mean, be creative. Just be creative, be flexible, because they may push you in different directions. Yeah, the distance formula is one of the main formulas to memorize too, so I want to see what you got. So what is it? Alright, so let's say I start off like that. Subtract your x's squared plus? And why is it plus right here? Because?
You're adding.
Because not only is it the distances that the x's are apart, it's also the distances that the y's are apart. So it's x minus x1 squared, y2 minus y1 squared, combined distances. But the proof of that formula comes from Pythagoras. Okay, it comes from Pythagorean theorem. All right. A spherical ball of liquid gel with a radius of 4.2 centimeters is poured into a right circular cylinder that has the same radius. Approximately how high up the cylinder will the gel reach? I don't know why we're talking. Not here. Okay, we can't do that. Won't work. You got 20 people. All right, what do I got? I got a spherical ball of gel. Yummy. And you're going to reshape it into a right circular cylinder. Again, don't let the right scare you. Right just means it's not oblique. It's not slanted. Oblique is like this, or it's sideways, okay? So I'm taking this ball, now what's the radius of it? It's 4.2. And whatever liquid I have in here, I'm going to go pour it into that. Now it has the same radius, so that's 4.2. I just want to know how high up is it going to reach. And I don't need to figure out what's the discrepancy between the heights of that and the other, just you're going to find the height. The bottom line is, you know that and this is how I think Kailani did it. Kailani said the volume of the sphere basically is equal to the what? Volume of the cylinder. Whatever fluid I have, whatever gel that I have, I'm going to put it into the what? Cylinder, so that their volumes are the same, because you have the same amount of material, whatever it may be. You know the radius, what is it? 4.2. Pi now you're going to let be 3.14. Should you just then change 4/3 to a decimal? Might as well, right? 4/3 is what? 4 divided by 3, so that's 1.3333. take as many 3's as you can, equal to pi times the radius. Now, you're saying, why did you substitute for pi? Why didn't you just let the pi's divide out? I could have, right? If there's pi's on opposite sides, they would have basically went bye-bye. And then don't get cute from there. Oh, r cubed and r squared, so that means there's just one r left, and yada, no, be careful. Okay? That works, but be careful. But all I did was what? The amount of liquid here pours into this, so I know the radiuses, I just don't know the height. So again, that's that philosophy. Plug in what you know, solve for what you don't know. Solve for what you don't know. All right, consider a pyramid. All right, if the volume's decreased by 25%, what would the new height be? So let's say I had a pyramid. Let's say I had a height of, I don't know, 12 with a base of 10. If you decreased the volume, not the height, if you decreased the volume by 25%, what would the new height be, considering I guess they're going to leave the bases the same, 10 by 10. So they want me to know what's the new height. So first of all, how much volume do you have to work with here? So what's the volume of a pyramid?
1,200, I think.
Oh, okay, you're right. But what's the formula?
1/3.
1/3 base times height. Miss Emily already got it. That girl. I think it's 1/3 of 100 times 12. So the actual volume is 400. I think. Because what's the area of the bottom? It's 100. The height's 12. What's 1/3 of 12? It's what? 4. 4 times that. So the volume of the pyramid's 400. So then now you're going to decrease it by what? 25%. So that means take 25% away. So you'd say 25% of what? 25% of 400.
300?
So what's 25% of 400? It's what? 300. Oh wait, my fault.
I mean,
It's
100.
And so you're going to take that away. So what's the volume of this one now? The volume of this one is 300. Follow me? So I found the volume of the pyramid, which was 1/3 base times height. That was 400. Well, you're going to decrease it by 25%. So you're going to take 25% away. So the natural question would be, what in the world is 25% of 400? So I just multiply it. It's always a multiplication problem. So 0.25 times 100, or you do it in your head. So take 100 of away. So now the new pyramid's got a volume of 300. So what would the height be? So I would go use the same formula. And you know that the volume's 300. Plug in what you know, solve for what you don't know. You know the base. It's 10 by 10, which is 100. You just don't know the height. Now you're like, yeah, but I don't like the 3. The 3 and the 100 doesn't divide. What else could you do? You could battle axe fractions. You could multiply both sides by 3. And so that's actually 100h is 900, so h is 9. Now, was there a shorter version to do that? Yeah. So, some of you, yes.
I just took, I just multiplied 0.25 by 12 and then subtracted that number from.
Right? That's all I could have done. Now, be careful with that, but that's right? If I'm going to keep the base the same, then really all I'm tweaking is what? The 12, theoretically. So what's 1/4 of 12? 3, so basically the height's 9. Okay? Yes, that worked for all you guys out there that are sharp cookies, okay? But I just, it's all right. This one was on the released items. I just want to show you how to set it up. It's a piece of cake. They said a right circular cylinder is shown. The cylinder has a radius of 9 and a height of 6. If the radius increases by 3 inches, what's the increase in volume in terms of pi? So here's what you do. Basically, you have the old cylinder, which is this. Then you got the new cylinder that had what? The radius increased by 3, so that means it's now 12. Keep the height the same. So how much bigger is that? And you would just subtract them, right? But you would leave your answer in terms of pi, so don't plug in pi. If I had a calculadora, I would say, well, 9 squared is 81. 81 times 6 is a lot. So that's 486 pi. Minus, now whatever, well I don't want to minus that way because I'll have a negative, it's okay. My new one is 864 pi, so how much bigger, or how much did it increase, so what would I do? 864 minus 486. So it increased 378 pi. Look how unfair that multiple choice question was. Did they have the volume of the old cylinder there? Yeah. Did they have the volume of the new cylinder there? Yeah, but what did they want? the increase in how the volume. So just don't be a victim, okay? Don't be a victim. Make sure you read the question. Don't be Mr. Simpkins and don't read questions, all right? So make sure you read the questions. All right, I wanted to do surface area and volume first today. I might go back to this. Oh, you know what I want to go back to? When Ethan left. That problem right there is mucho important. This again was a released item. Avoid talking to whoever you're sitting next to, right? You gotta avoid it. You gotta just pretend they're not there. An artist is making a stained glass piece of art. The stained glass is a sector. It's got a radius of 3. The arc measure. Now remember, arc measure. Wait a minute. That's not. Ooh, tricky. Arc measure means what? This angle in degrees. Not degrees per se, but in angles. So they didn't say arc length. I read it as arc length. It's not. So basically, what do I know? I know that the measure of this angle is 3 pi over 4. Which a central angle is the same thing. It's just what? This answer is not in degrees. It's in radians. Remember, radians has pi's in it. You with me? Come on, this is an important one. So they gave me the sector, but they gave it to me in terms of radians. No big deal. So it's not degrees. So it's 3 pi over 4. All right. How am I going to get the area of this sector? Well, what I would do is I would change that into degrees. All right. So let's see how sharp you are. How do you change radians into degrees? Do you multiply by 180 over pi or pi over 180?
180 over pi.
Good, because you want the pi's to go by pi. So that's what? 540 divided by 4, which I usually memorize, but I'm old. 135 degrees. So what did you do? I changed the radians into degrees because that's how I flow. So now what am I going to do? I'm going to say, well, I just basically want this now. I want the area of the sector. It's 135 degrees. The radius is 3, so here we go. Area of a sector is a piece of 360. And it's 135 of 360. And so that's what? 3/8 if you're good at fractions. 135 over 360 is 3/8 of 9 pi. You're like, yeah, this doesn't come out very nice. No, they told you you're not going to get nice answers. So 27 pi over 8 is the area. You're like, so that's a pretty crazy problem. Yeah, that was one of their old test questions. So if you want to know what's it going to be like, that's like it. So think about all I did there. All I did was I took what I'm not good at, radians, put it into degrees, and I mean, how much did we started today? We started today saying what? These are probably 2 of the most important concepts on this test. Believe it or not, at least it's a theme, fractions. Not the whole area, not the whole circumference. Pieces, pieces, and pieces. All right, we got it. I think we hammered that thing in. Did we beat that horse up? All right, density. Density. A circular survey was done in the Ocala National Forest and discovered that there was 12.91 owls per square mile. If the Ocala National Forest is approximately 3,000 acres, how many owls would you expect? Expect, my fault. I was typing in the dark. So what do you think? I got the Ocala National Forest. They did a survey of what? A circular piece of land, and they knew the density. It was 12.91 owls per square mile. So now they're saying, well, how many owls would you expect in the entire national forest if it's about 3,000 acres? Well, the problem is what? This is in miles squared, and this is in acres. So I probably want to convert either the miles squared to acres or acres to miles squared. I would do this. I would convert the acres into square miles. So if it's 1 acre for this many square miles, how many would 3,000 acres be? So that's a multiplication problem, right? So 3,000 times that's not even the right numbers. Let me pick kind of a number that's better. So it's about 4.68 square miles. 3,000 acres is roughly 4.69 miles squared. So you with me? So what's the owl's density? There's 12.9 owls per square mile. So if this is how many square miles it is, what do? I just simply multiply. Hopefully that, you're going to get some density problems, that's for sure. You're going to be surprised. So it's about 60 owls, which is not many. All right? All right, there are blank people in this room. So how many think there are? I'm going to count. It's just 1, 2, 3.
So you don't count that? Just gotta be English.
This
It's about 50.
Signage?
Alright. Yo.
I think it's like,
Yeah, I'm going to send it around. So there's 50 people. Okay? 50 people in this room. Come on. So each of you emits 1,200 BTUs each, whether you like it or not. You're giving off heat energy. So you guys are giving off 1,250 BTUs each. So if there's 50 kids, then I times that by 50 to figure out the total BTUs that's going on in here right now. So 1,250 times 50. So there's about 62,500 BTUs total. Now, if the room is 10 feet by 60 feet by 35 feet, remember density is how much stuff did you cram in a certain amount of space. So here's all you monkeys, right? Here's all you people in here. You're giving off 62,500 BTUs. The dimensions of the room is a 10-foot ceiling, 35 feet wide, 60 feet long. So the volume would be, what, 10 times 35 times 60. So that's a total of 21,000 cubic feet. So when I do the division here, what's my label? When I do the division, my answer is going to be what? BTUs per cubic foot. When I do the division, it's going to be BTUs per cubic foot. So it's about 2.97. It actually comes out to like 3, but let's just pretend it's that. So that's how many BTUs there are cubic foot. All right, let's say we had to move to a room now because this room's like hot. And we got to go to a room that has a ceiling that's 2.5 feet lower. How does the amount of BTUs decrease? You're like, wait a minute. So if I go to a shorter room, what is it now? 7.5-foot ceilings? That's not going to be comfortable. People are going to be sweating. There's still how many BTUs in here? 21,000 BTUs. So then I would just take 21,000 BTUs divided by what? The area now, the volume is 7.5. Now, is there a quick, is there?
262.
Oh, so, yeah, what did I say 21,000 for? Oh, okay, good. Oh, thank you. Hey, I still did that wrong. All right. 62,500 BTUs. Good. There's still that amount of BTUs going on. My new volume is 5750. So how does the density decrease, right? How does the density, because it's BTUs per cubic foot, so now 62,500 divided by 15,750. The BTUs are now 3.96 BTUs per cubic foot. And you're like, well, they didn't decrease. It increases. Why?
Because there's less space.
There's less space, but there's still the same amount of what? People crammed in it. So it's not decrease, it should be what? Increase. And how much did it increase? Well, 3.96. Subtract that, so it increased about 1. About 1 BTU per cubic foot. So BTU is just a British thermal what, unit? All right, let me hand around the clipboard before I...
Wow.
So make sure you get your name in here. So first let's start with polygons in general. What's the angle formula for the interior angles of a polygon? Actually, there are way more people than that. What are the interior angles of a polygon?
N minus 2 times 180.
Times 180. Right? N minus 2 times 180. It's always the number of sides minus 2. So if I had a 1, 2, 3, 4, 5, 6, 7-sided figure, it should be 7 minus 2 times 180, which is 900 degrees. Okay, so it should be about 900 degrees. Now, not the exterior angles. The exterior angles add to what? 360. All right, a quadrilateral has how many sides? 4. I just always throw that in there because some kids, what's a quadrilateral? I have no idea. All right, decagon. 10. If it's 7-sided, what's it called?
Septagon.
Who do you think it would be? It's heptagon. Nonagon, how many sides? 9. All right. My daughter said, yeah, you actually had to know how many sides and the names of things. So make sure you brush up on your names. So decagon's 10. All right, facts about parallelograms. No, by definition, opposite sides are parallel.
Yeah.
If I'm doing a proof, If I'm doing a proof, they're going to say opposite sides are parallel, definition of a parallelogram. Now, by theorem or postulate, remember postulate's just a rule that you don't have to prove. It's a rule that you don't have to prove. It's a rule that I accept without proof. A theorem is a rule that I have to prove. But either way, it doesn't matter whether it's theorem or postulate. All my properties of parallelograms are what? Opposite sides are equal. Opposite angles are equal. What about this one? The diagonals bisect each other. Does that happen in every parallelogram?
Yes.
Yes. But in a rectangle, what's true? Well, the diagonals are actually equal. So all these pieces are equal. But not in a rhomboruski, right? A rhomboruski, the diagonals just simply bisect each other. But the diagonals are what? Perp? The diagonals make right triangles in a rhombus. They don't make right triangles in a rectangle. And again, I want to keep all these facts straight. The diagonals also bisect the angles in a rhombus. Again, I don't know if that theorem is going to be used as much as, the diagonals are perpendicular, or in a rectangle that the diagonals are equal. Now remember, a square is regular, so it's both equilateral and equiangular, and it has everything. A square is a rectangle, so all the diagonals are equal. A square is a rhombus, so the diagonals are perpendicular. Remember, all the sides are going to be the same because it's a rhombus, and all the angles are going to be 90 because it's a rectangle. So it's both a rectangle and a rhombus. Remember, a trapezoid is not very special, just one pair of sides are parallel. A kite is kind of special because it's two, what? It's two isosceles triangles connected. Whether I have the kite looking like that or I have it looking like this, but nevertheless, and they'll probably draw both diagonals. What do the diagonals look like they do in a kite? They look like they're perpendicular. All right. The isosceles trapezoid is kind of special, right? An isosceles trapezoid has the legs are equal. It has that the base angles are equal. So let's do a proof with it. Consider isosceles trapezoid PQRS, where PQ is parallel to SR. Now they drew both diagonals, so that's interesting. Because the diagonals are equal in an isosceles trapezoid, but I don't think they're going to use it. So this is the drag, the reason. So look at all this stuff. You can drag congruent triangles, you can drag properties, diagonals of a quadrilateral are congruent, which that's not true. Diagonals of an isosceles trapezoid are congruent, or diagonals of a rectangle are congruent, but is this true in all truth? The diagonals of any quadrilateral are congruent. No, the diagonals in a rhombus aren't congruent. So that's a quadrilateral. But anyways, so let's read the proof. They first state the given, isosceles trapezoid, yada, yada, yada. This is parallel, mark it. All right, PS is equal to QR. Why? Well, definition of an isosceles trapezoid, because the definition is an isosceles trapezoid is a trapezoid where the legs are equal. The legs are equal. All right, so we're looking pretty good. Base angles of an isosceles trapezoid are congruent. All right, so that means what angles are equal to what angles. So I got to go find them down here. Oh, God. Is it this one? QPR is equal to SRP. QPR. Is QPR equal to SRP? What? No. That's this one. No, that's not it. Is SPQ equal to RPQ? Or what? RQP. The answer is yeah. So is this angle equal to this one? Yes. So that's what I would drag. I would drag it and drop it right on in there. Right? So that's the angle. Just follow. We need some experience with some proofs. All right, reflexive property. That means they shared something. What did they share? Well, this is not an easy proof. Well, I like this proof. Here's what they're up to. Ready? Here's what they're up to. They're trying to prove that this triangle, I hope I can draw this, is congruent to this triangle. Let me put the letters in here. PQR, PQ, what is it, S? Because watch, they said this side's equal to this side, right? That was the legs. They just said that this angle is equal to this one. If they're using the reflexive property, there must be something they're sharing.
Oh, PQ.
It's what? PQ equal to PQ. You're like, oh, you little suckers. All right, so I would drag that one in there. Now, do I have enough to say that those triangles are congruent?
Yes.
Yeah, what's the reason why this blue one is congruent to the yellow one? Why are they congruent?
Side angle side.
Good, side angle side. So I'm going to drag drag that, right? Side angle side is the reason why they're congruent. You got to figure out which one of these it is. I don't really want to know. I don't care. Once the triangles are congruent, then any of their parts are congruent. So what are they up to? They're trying to prove. I don't even know what they're trying to prove. Where do you see that? Oh, there you go. Bingo. All right. So they're trying to prove that PR is equal to SQ. They're trying to prove the diagonals are equal. Okay, I got you. So CPCTC is probably going down here, isn't it? Yeah, I'll bet I have to drag it. So they probably don't want me to do step 5. They probably don't want me to do step 5. Because I would use CPCTC, right?
They have CPC.
Where is it at?
Corresponding
It's the
parts.
corresponding triangle.
Alright, I can't see.
It just doesn't have.
It doesn't have the acronym. Alright. So they are going to drag that in there. And I'm not sure what they're going to say is congruent, but I think they're going to say that this is equal to this. So it'll be SQ, I can't even see this, the PR. I don't see it. Maybe not those equal then, so maybe it's somebody else equal. Whatever. But what a good proof, huh? I like it. So you had, again, the definition of trapezoid means the legs are equal. Then you got the angles equal. Now once they do that, you got to basically think about triangles being overlapped, which reminds me. The one proof we didn't get a chance to go over was the EOC 10. So I brought it with me. It's a triangle that overlaps. And they're nice. So this was the EOC 10 review. So let me walk through this proof with you because it's pretty good. Alright, the first thing they're going to try and do is they're going to try and prove that this triangle is congruent to this one. Alright, follow me. Alright. So how do I know that? Well, just because the way they start talking about stuff. They start talking about BC was equal to, let me do it in red. BC was equal to this. Then they said angle 1 is equal to angle 2. And then they went BEC, which is this angle, is equal to this one. Now why are those equal, by the way?
Vertical angle.
Good, vertical angles. So I had enough to say that this yellow triangle was congruent to the blue one. Now why? Cover it. Oh, I can't. Alright, why are those two triangles congruent? You got 2 angles and a side, 2 angles and a side. So why is the yellow triangle congruent to the blue one? Angle, angle, side. Now, once the triangles are congruent, any of their parts are congruent. They chose to say that this was equal to this. Reason CPC TC. I can hear you guys mumbling. You probably just need to not sit next to each other. Alright, so once the triangles are congruent, now they go on to another mission. They say CF is equal to AF. You're like, where's this at? Oh, that's another part of the given. Do you think that they would save the given that far apart? It's possible, isn't it? So in the given, they stated one piece of it, but because they weren't using it now, they're saving it for what? Later. Well, that's fine. They can do that. They're big boys, big girls. So now what did I mark? I didn't mark it. So that's what? CF is equal to AF. So let me draw these triangles. Here's what they're up to now. Now they're trying to prove that this yellow triangle is congruent to the blue one. Think about what you know right now. You know that, well, they're going to share a side, so I bet you they're going to use reflexive property. Bingo. Right? EF is equal to what? EF? And they have that this is equal to this. And then what else do they got? They're going to say side, side, side. You're like, how do they get side, side, side? Oh, they have this part, right? This was congruent to this. And so those triangles are congruent by side, side, side. So it's a good proof. You basically proved 2 triangles were congruent twice in that same problem. So you went with the yellow and blue triangles congruent by angle, angle, side. Once those triangles are congruent, CPCTC means another set of people are congruent. Then they moved on to prove another pair of triangles are congruent. So pretty good. Alright, so since I'm on this, let's do this. Is it 9 or 10? Yeah, it's 10. Alright, we did not get a chance to go over this in class very well. I'm just going to go over a couple of them. Create an expression that talks about the arc length, or my fault, the area of any sector for a radius or for an angle of x. So is everybody down with that's the expression you have to type in the computer? You have to type that expression into the computer to say x of 360 times pi r squared would represent the area of any sector with an angle of x. All right, this was that palm tree problem. If you take tubes, small little tubes that carry water, how many tubes could you put into a palm tree trunk if each tube has a very dinky radius? What is it, 0.003 meters? And the diameter of the actual palm tree was a half a meter. And so what I did was I just simply said, well, how much space is this going to take up? How much space is one tube going to take up? To me, space that you take up is the same thing as volume. So I'll find the volume of this little cylinder, and I'd say, how many of those can I fit in there? Well, what's the volume of the cylinder? How much room is in there for the cylinder? So I found the volume of the small tube, I found the volume of the big tube, and then I divided. How many of these little tubes could I fit in this big guy? I divided, and so I simply got whatever it was. 2,803,571 little pipes. That was on a practice test for you guys. So did you see what I did there? I just basically said, how much space does this little thing take up? And my daughter said there was things like this. She said that there was kind of like candles. Remember I did candles in a box? And I said, how many candles could you fit in a box? Well, again, think up about space. How much space does it take up? And then put it in there. Yep. We're going to take a break in a second. Don't worry about the height. Why did you not worry about the height? Well, because if the height of the tube is the same as the height of the cylinder, the height's a moot point. It doesn't really matter. It's about the radius. So there was another way you could have also thought about that, but I pretty much ignored the fact of the height. Just ignored it because it didn't matter, right? How do you change again radians into degrees? Multiply it by what? 180 over pi. So if I want to change 2 pi over 3 to degrees, then multiply it by 180 over pi. If I want to change degrees into radians, then it's pi over 180. Because I don't mind having a pi in my answer. Now, does anybody remember what's the biggest that an angle could ever be when it's in radians? 6.28. Good. The biggest that an angle can be when it's in radians is equivalent to the circumference. Because remember, what is the definition of a radian? It's the length of the arc compared to the radius. So if I'm talking about the biggest an angle can be, which in degrees is what? 360. The biggest an angle can be in degrees is 360. So if I said, all right, if the length of this arc is the entire circle, what is that? 2 pi? And I always compare it to the, or 2 pi r, and I compare it to the radius, right? Because that's the definition of what a radian is. It's the length of the arc to the radius. So the entire circle, if I talked about it, just like I talk about 360, it'd be 2 pi r. No matter what the radius is, that's that. So the biggest a radian can ever be is 2 pi, which pi is 3.14. It's 6.28. So if you ever get an answer where you're converting radians into degrees, or my fault, degrees into radians, and you have something that's bigger than 6.28, you probably did something wrong. All right, moving on to a couple more proofs. And then the last part should go pretty fast. Like I did the harder parts first. I did the harder parts first. Now again, if you didn't get on this clipboard, make sure you get on it before you leave, okay?
Where'd you say to put the money?
Oh yeah, the money right here. So I made a chance to just try to collect it. Because we're going to find that.
I got the big bands.
Yes?
Is it possible I could get a copy of these problems?
Yeah, it's a mess though, but I don't know how to do it. I could try. Maybe you can take it. Alright, there we go. Given a rectangle, M is the midpoint of WX. Prove that ZMY is isosceles. So I'm going to do a proof from scratch. So again, first thing I do is state my given. So what do I have? I have a rectangle WXYZ. And M is the midpoint as well. So I have two givens. Now, just because you state a given, you need to mark some things. So the first thing is, if M is the midpoint, is it true that these are equal? And you'd say, yeah, WM is equal to MX. Reason, definition of midpoint. Now, because it's a rectangle, I'm going to go opposite sides are congruent. So WZ is equal to XY. Now, you could just say if rectangle, opposite sides are equal. They might have on there, if it's a rectangle or if it's a parallelogram, then opposite sides are equal because a rectangle is a parallelogram. There's another thing of rectangle that I didn't use, and I'm going to use it right now. Don't the angles in the corners, aren't they 90 in a rectangle?
Yeah.
So I would say angle W is 90, angle X is 90. Now that might be definition of a rectangle because a rectangle by definition is a quadrilateral, my fault, it's a parallelogram. It's a parallelogram where all the angles are 90, or all the angles are equal. So they might have it as definition of rectangle. Now tell me why this yellow triangle is congruent to the blue one. Why this triangle is congruent? I heard one person, I should hear what they are. Good, side angle side. So the triangles are congruent by SAS. Now, once the triangles are congruent, there's probably going to be something to go prove somebody else is congruent, yada yada. So they do. I'm able to say that MZ is equal to MY, and the reason would be, right? Remember, once the triangles are congruent, then these parts are congruent. Well, do I have enough now to call that triangle isosceles? Because that's what I'm asked to do. Can I call it isosceles now? Why? Because two sides are equal, and the definition of an isosceles triangle is a triangle that has two sides are equal. So I just stated my rectangle. I used that opposite sides are equal. I used the midpoint thing. I was able to prove the triangles congruent. Once the triangles were congruent, then parts were congruent, and that was what I needed to do, what I needed to do. All right? I don't have the equal sign like I said on my computer, so this is all I got. Try and resist. All right, here we go. I got a lot of people equal here. Watch this. HS is equal to SB. RS is equal to SO. Like, darn, they're giving me everything. And then HO is equal to HR. I'll do triple stripe. So that's a lot of giving. You're like, yeah, is it done already? Because they gave me like everything for Christmas here. Do I have enough to say these triangles are congruent? But I'm not sure if that's what I'm doing. So here's what I designed this for the reason. So I stated all this given, right? HS is SB, RS is equal to whatever. So that was given. Here's what I'm going to do. I'm going to say that HOBR is a parallelogram. You're like, wait a minute, how could you call that a parallelogram? Why?
Because it's I know that you.
Ooh, the diagonals do what? They bisect each other. If I have a quadrilaterals and the diagonals bisect each other, is that enough to call it a parallelogram? Yes. Okay. If I see a four-sided figure and the diagonals bisect each other, I can call it a parallelogram. Well, why would you call it a parallelogram? You could have already proven these triangles are congruent. Yeah, I could have. I decided to do something different. So, and again, they're going to do the same thing. So now, what am I up to? Well, now that I've called this a parallelogram, now that I've called that yellow thing a parallelogram, I know that what? Opposite sides are congruent. So HR is equal to BO, and RB or BR, either one. BR is equal to HO. Reason? If parallelogram, opposite sides are equal. So I went and proved that it was a parallelogram. Now we're going to put all this transitive logic together. If I put a number here, everybody know it. Didn't I say at the beginning of the proof that this guy was equal to this guy?
Yes.
Okay. That he was equal to him. Now I've just said that opposite sides are equal. So if he's 9, what's this dude? 9. And if he's 9, what's this guy?
9.
So they're all... So with transitive logic, they're going to do this one. They're going to say HR is equal to HO, which is equal to BO, which is equal to BR. Reason? Transitive logic. Transitive property. Because if they're all equal, now could I call it a rhombus? Now, is this the only way to prove this? No. A rhombus is a pretty awesome shape. There's all kinds of ways to prove that something's a rhombus. I could have done it with the diagonals being perpendicular. All right, similar. Similar is huge. Okay, similar means they're not the same size, but they are the same shape, right? The angles are equal when it becomes similar, but not the sides. The sides are what? Proportional. The number one thing that we use to prove similar is what? 2 angles equal to 2 angles. I could have a situation where I've got 3 sides that are in the same ratio as 3 sides. So if I had this, this would be considered similar because they're all in the same ratio, whatever. If I have a shape inside a shape, what am I doing here? If MN is parallel to AB, I could draw the picture, I gotta remember what I did. Oh yeah, no, now I know. So let's say I have a triangle ABC, and I have a situation where MN is parallel to AB. And then they say find X, right? So I'll say X, 4, 9, 12. So I'm going to find X. Now, anytime I had a shape inside a shape, I always begged you to redraw it. So what do you mean by that? Well, I mean that the small triangle is similar to the big dog, is it not? The small triangle, which is 4 by 9, is similar to the big dog, which, be careful, what's the length of the segment?
4 plus X.
Good, it's not just X, it's what? 4 plus X, and what's the bottom? 12. Now the reason why they're similar is, well, you gave me parallel. If you give me parallel, it's like pretty awesome, right? I got corresponding angles are equal. I got these corresponding angles are equal. They share an angle, which is called the what? Reflexive property. So I had all kinds of angles. They share an angle, yep, yep. I got all kinds of stuff. Either way, now I do proportion. If I did my proportion this way, 9 is to 12, how would I finish it? 9 is to 12 as, if I started it as 12 is to 4 plus X, how would I finish it? 12 is to 4 plus X as, right? Proportions are flexible. But however you start dictates how you finish it. All right, on similarity, they may, you don't know if it's similar, but the way they talk, watch. MNP maps onto M prime, N prime, P prime, where Mn is this, M prime's 9, M prime, P prime's this, yada, yada, yada. So when they say that MNP maps onto another shape, then I already know it's similar. Okay? Well, it could be congruent, actually. So MNP maps onto another shape, but I realize it's similar once they said this is 12 and this is 9. If this is 15, well, this is 15, then what's X? So I realized they're not the same size now, right? They're not the same size. Even though they mapped onto each other, they're going to be similar. All right, another thing with similarity. Do dilations lead to similarity? Yeah, when you take something and you dilate it, you either make it bigger or smaller. So that means it's still what? It's still similar, and if it's similar, then they're proportional. So anytime I say, if I took a shape and dilated it by a factor of 1 to 4, it's still going to be similar, right? It's still going to be similar. It means the size of this is going to be 4 times bigger, whatever it may be. If this is treated as distance from a point called the center, then I have to know, is the center the origin, or is the center not the origin? So that's a big deal. So let's say the center is negative 1, 1. And this point's, 2, 2, this point 6, whatever it is, 3, yada, yada, yada. So let's say I dilate it by 1/4. If I think about that like distance, because if it's on a grid, I got to think of it like distance, what am I going to do? It's going to be 1/4 of the way from the center. It's 1/4 of the distance from and the center's the biggest part of that, isn't it? It's always about distance from the center. So you'd say, okay, how far is 2, 2 from negative 1, 1? You'd say, well, I'm going to do that bit by bit. How far is it from negative 1 to 2? It's a distance of what, 3? So you're going to take 1/4 of that distance. Now, it'll probably come out nicer, but now it's going to be only 1/4 of the way from there to there. How about this guy that's way up here? It's at 3, 4. Now it's going to be not all the way there. It's going to be what? 1/4 of the way. So what's 1/4 of that distance? So if I looked at the x's, from negative 1 to 3, how far is that? From negative 1 to 3, that's a distance of 4. So what's 1/4 of 4? 1. So I know that the x-coordinate for this figure is 1. Now to get the y-coordinate, again, it may or may not come out pretty, but it probably will. But when they talk about dilating and they do it on a graph, it's all about distance from a center. So how far is this dude? All right, cut the distance by 1/4. If it's this guy, cut the distance by 1/4. And if I do that for every single point, what's the end result? You create a what? Figure that's how much compared to that? It's what? 1/4 the size. Oh, that's that was one. If it wasn't the origin. All right, crackhead. this is when you go too fast. If it's the origin, did I have to do all that?
No, you don't.
No, I went like, okay, so let's swap. This is if it's not the origin. If it were the origin, it's polar sausage, right? You would take 2, well, it's 2, 2. And if it's the origin, and that's the center of the dilation, so my fault. I think I confused you. Well, I know I confused you. If this is the center, okay, then that's how it works. So that's when it's not the origin. If it is the origin, it's a piece of cake. You just do what? 1/4 times 2, which is a half. 1/4 times the other coordinate, which is 2, so that's a half. So it's what? 1/2, which you can do. If I know, hang in there. If I look at the point 6, 3, if the center's the origin, what's 1/4 of 6? Right? You're like, oh, that's easy. That's 3/2, right? 3/2, which is 1.5. So now it's not going to be right. It's going to be right here. What's the other coordinate? Well, what's 1/4 of 3? So all I have to do when it's the origin is the center, I just multiply the coordinates, right? What's 1/4 of 2? What's 1/4 of the other guy? What's 1/4 of 6? What's 1/4 of 3? Still the same result. The same result's going to be, let me draw my picture. Yeah, I had it backwards. My result's still going to be the same, but it's going to be a figure that's 1/4 the size of the original. Did I lose you? You could drop a pen in here right now. Y'all just went into a food coma. Are you all right?
Yes.
I got caffeine back there. Did you suck it all down? Yeah, you did. Holy cow. What are you all messing around? 8 2-liters of soda y'all just put down. Shame on yourself. Call everyone in home and have them help. All right, so dilate. Yeah. If the center's the origin, it's easy. If it's just a point -1, 1, it's a little harder, but just do it point by point. All right, let me do one where they overlap. So what happens when you dilate and one of the points is that of the shape is actually the center? So let's say I took this one. Now we did one of these, so we'll do it pretty quick. I want to make it 4, 6. I'm going to dilate it by a half with the center M. So we'll make him the center. So this will be shape man. I don't know who's talking. Just resist talking for now, right? Talk later. Call each other all day and night. I don't care. Just shush it. Got it? Shush it. All right. Dilate it by a half. Dilate it by a half. Now who's the center? Ooh, that's going to be tough. Maybe I should draw a better picture. I'll do one where the numbers come out nicer. So I'm going to go 2, 2. So here's the figure, and then man, I'm going to go make 6, 2. All right, so the bottom line, first of all, is who's the center? I'm actually making it one of the actual points of the shape. So the center of the dilation's that guy. So think about it. Every dude is now going to be not this far away from the center. It's not going to be that far away from the center. Now it's going to be, what, half the distance. So there's the new point N prime. If this was A, now A is going to be what? Dilated by a half. Now it's half the distance from the center, so now it's going to be right here. So the result is this. There's the guy that just got dilated by what? A half? Make sure you got this down. And then they're going to ask you questions like this. Is it true, and let's put the letter here, does MA overlap with M prime A prime?
Yes.
Yes, they overlap. In other words, the side, this little segment MA overlaps with that guy MA. All right. Does the segment NA equal half of N prime A prime?
Yes.
Yes.
Wait, no. No, it's the opposite way.
Good, it's the opposite way. Goodness, Emily, right? It's the opposite. NA is twice as big as N prime A prime, so be careful there, and they'll have that. They'll say, is it true that it takes, well, you can do it this way. It takes 2 N prime A primes to equal NA. Yeah, it takes 2 of those to equal that, because again, This shape, the red triangle, is now half as big. I dilate it by a half. But again, when you're getting these numbers and you dilate, think about distance. Distance from a center. And if M is the center of the dilation, everybody's shrinking, in this case, towards the center. Now if I dilate it by 2, so if I change my mind, hey, let's dilate it by 2, then it's going the other direction, right? Now N is not this far away from the center. The center's M now. Okay, we're using this as one of the centers. Now it's going to be where? Way out here. And A would be way out here. So their distance from the center now is doubled if I go the other direction. All right? So they'll do that kind of stuff. All right. This question has 3 parts, yada yada. We're only going to do like 1 or 2 parts. And I'm going to go quick. All right, here we go. So select all the assumptions that must be made to show that they're angle-angle similarity for triangles. List all the people of assumptions that if these triangles are similar, but they tell you they're similar by a certain method. They're similar by what method?
Angle.
So do I care about proportions? No, that's if they're similar. If they're similar, then things are in proportion. If they're similar, then things are in proportion. So don't fall for that. What about S equal to Q? Would S be equal to Q help me to prove that triangles are similar by angle-angle?
No.
Yeah.
Oh, wait.
If S is equal to Q, I'm trying to prove these triangles are similar. If I'm trying to prove by angle-angle, could I accept one of those as one of the reasons to help me prove that? Yes. How about S is equal to P? Well, possible. It depends on how you did it. Oh no, they did a certain order, didn't they? PQR is similar to what? TSR. So that wouldn't be the correct order. True, watch. Remember the way in which you write it? It has to be particular. Who would Q have to be equal to? I circled it. Q would have to be equal to R. Who's equal to S? It's the middle letter. S is equal to which one? R. Ooh. Ooh. Right? Neither one of those are good. So Q would have to be equal. Why are none of those working? S is equal to P. This may be bad. This is a bad problem, actually. Ooh, that's their fault. That ain't my fault. That's not what you want. Boy, that came from the FSA practice test. If they're trying to say that these are similar, maybe they're saying no order is established. That'd have to be it. That's a bad question. Order would matter, and that wouldn't then follow. So I don't like that one at all. All right, which of these, though, would not result in a similarity? Select all the transformations that would be used to show similarity. Are you ready? Don't talk to your neighbor. Would rotating a figure followed by translating a figure lead to a similarity? You rotated it, then you slid it. Is that going to make anything similar? No. How about reflecting it and then translating it? So flipping it, then translating. Would that result in a similarity? No. Any of these transformations better have a what in it to make something similar?
Dilation.
Good. So the ones that work is a rotation followed by a dilation. That would result in a similarity. A reflection followed by dilation. That would result in a similarity. So the two that result in a similarity is anybody that has to include a what? Dilation. It's got to be. All right. Don't forget about Pythagoras, right? A squared plus b squared is c squared, right? Sometimes you may have a Pythagorean theorem problem where there's 2 Pythagorean theorem problems. Maybe you have to go 6, 8, 10 to then get 10, 12, blank. Maybe you have to do Pythagorean theorem twice to get something. Remember, if I want the height of an isosceles triangle, I know that if you what? Drop a height, what does it do to the bottom?
Cuts it in half.
Splits it. Now, is that a misnomer? Would that ever be true in math, that this is 20 and that's 20?
No.
No, that is wrong.
That's wrong, right? How could the hypotenuse be bigger than that, right? So this would have to be like, I don't know, 30 or something, right? So then when it breaks, you would then get the height, right? So when I drop a height in isosceles triangles, yes, Pythagoras, all day long and twice on Sundays. What some kids made the mistake of doing is that on isosceles triangles, they assumed, hey, isn't that a 60-degree angle in the corner? No, not necessarily, right? It's just an isosceles triangle. So when you drop a height, all you're guaranteed is it bisects. That's all you're guaranteed. You don't know about angles, nothing like that, unless they say it's equilateral or something like that. All right, a ladder when propped up 15 my fault, a ladder when propped up 5 feet from the wall reaches 12 feet up. If the dude moves the ladder 1 foot further, now how far up the ladder does it reach, or how high up the wall does it reach? So you had it propped up a wall, what was it, 5 feet from the base. So 5 feet from the base it reached up 12 feet. So now if you move it up 1 foot further, now how far does it reach up? In this scenario, was I able to figure out how long the ladder was? Yeah, in this one scenario, I was able to figure out, hey, you know what, the ladder is 13 feet. A squared plus B squared C squared. Now, when you move the ladder away, it's still 13 feet. So how high up does it reach? I would just simply say what? 6 squared plus x squared is 13 squared. And I'd get a decimal, it's not a big deal. All right, special triangles, what do you know? 30, 60, 90, what do you know?
90 is 2 times the 30.
2xx and x root 3. Who's 2x? Good, the hypotenuse. Who's the guy? Who's the small side?
Small one.
Good, good. Who's the guy across from 60? X squared root 3, right? Memorize it. Get a tattoo over the weekend, right? Get it done. Whatever you got to do, right? 45, 45, 90.
Isosceles.
Isosceles, what do you know? X radical 2. The cycle of life. If you're going this direction from the small side, you would multiply by root 2. If I'm going backwards, I divide by root 2. So just know that cycle. If I went from the small side to the guy across from 60, I would times it by root 3. Going backwards, I would divide. You still need to read the notes to keep it, what? Simple. I got to know my stuff. Don't underestimate or overestimate how much you need to back up and look at the basics. All right, let me look at this one. When a side, what is the side of a square that is inscribed in a circle that has a circumference of 20 pi? So I made this one up last night. So what is the side of a square if it's inscribed and the circle has a circumference of 20 pi? Tell me what I'm going to do.
Oh.
Find the radius.
Good, find the radius. Beautiful. What's the formula for circumference? Good, 2 pi r. So is that enough to find the radius? Yeah, it's 10. Now if the radius is 10, you're like, okay, that's from there to there though. How's that selling tickets? And then another kid may draw this radius. How's that selling tickets? Well, if I go all the way across, what's that, 20?
20.
Is that half of the square?
Yeah.
Ooh. So basically, if I want the side of the square, just basically now think of it as what? The hypotenuse of the triangle is 20. Although it's a square inside of a circle and I was able to get the radius, I understand radius is half, so the entire diagonal would be 20. And then again, I'm going from the hypotenuse to the small side, to the side of the square. So I divide by what? By radical 2. So let's all brush up on our facts real quick. What's 20 divided by radical 2?
Multiply it by radical 2.
Good, you got to do this little method, right? You got to get rid of it. Is there a shortcut? Yes. Do I teach it? No. What's radical 2 times radical 2? Radical 2 times radical 2 is the square root of 4. Square root of 4 is 2. Do the 10 to the 20 and 2 simplify.
10 radical 2.
Brush up on your basics, okay? Those are basics. We haven't done many of those basics lately because we've been cranking up all the hard stuff, all right? That's just why we did that. So brush up on that. Look at your EOC stuff on that. Trigonometry is what? The ratios of the sides of a right triangle. Just remember that. Right triangle. So-ka-toa. So if I want to find a side, and this is, let's say, 49 degrees, and this is 17, I would use tangent. So tangent of 49 is 17 over x. If x is on the bottom, I don't panic. I just multiply by x, and then I'm going to have to finish it by dividing by what? The tangent of 49. If I want to find an angle, that's again different. So in this case, if I want that angle, I want to use what? Cosine? Why cosine? Because it involves adjacent and hypotenuse. So the cosine of x is 7 over 10, but anytime I'm looking for an angle, it's different than when I'm finding a side. When I find a side, I just go opposite over adjacent, and everything's fine. Take 17 divided by the tangent of 49. Here, I can't take the cosine of thin air. What's the cosine of x? I don't know what x is. So this is where we use what? Inverse. Or what? Arc tangent, right? Or I call arc cosine. So it's either cosine -1 or arc cosine. They may do trig in different ways, like I said. If they said the sine of x is 8 over 17, what's the cosine of x? All right, so Gaia and Roxy, it's not working out. You're sitting back there and you're just talking. So you may want to find another spot. It's not working. All right, sine of x. Sine of x is what? I mean, you're like, what the heck is this? Well, isn't sine opposite over hypotenuse? So if I said the sine of x is, what does it say, 8, and that's 17, can I just say that the guy opposite is 8 and the hypotenuse would be 17? Yeah. If they give me the ratio, this is a different way to talk about the trig, but if I did, that's true. Sine is opposite over hypotenuse, that's 8 over 17. Yeah, but when they ask for the cosine, I need adjacent over hypotenuse, and I don't know what's adjacent to it. Yeah, but who does know it? Pythagorean theorem knows it, right? Pythagoras knows it. So Pythagoras would say, dude, it's 15. If you use my theorem, I'll give it to you. Okay? So the cosine will be, what? 15 over, and they don't care about anything else. They just want to know what's the ratio. All right, what's the tangent of x? The tangent of x would be opposite over adjacent. So that would be the ratio 8 over 15. Notice they didn't ask me for x. They didn't ask me for x here. They just asked me, what's the cosine of x? So if the sine is 8 over 17, then the cosine would be 15 over 17, and the tangent would be 8 over 15. I don't know if they'll give you one of those, but it's not a bad question. All right, from the top of a 116-foot tower, the angle of depression to a fire is 4.62 degrees. So here I am. I see a fire. Okay. The angle of depression is what? 4.92 degrees. You're like, why'd they choose such a stupid number? Because they're stupid. All right, the top of a 116-foot tower, how far are you from the fire? So you have two options. You can either look at this triangle, or you can draw the what? The other one that looks like that. Either one, it'll still find the distance from the fire. Just understand where that angle of depression is generally outside the triangle that most kids pick. So if that's 4.92, what's this angle? 4.92. So you could do it that way. Or you could say, isn't it 90 minus that would give me this? Yeah, so it's 95.18. Oh, wait, 0.8. Or 85. So I could do either one. I could say, well, if that's 4.92, that's 85.08. Well, I don't know if I like that. So do whatever you want to do. Bottom line is you're going to use tangent. But if you use that angle, it's the tangent of 4.92 is 1/16 over x. If I use the other one, it's a different ratio. All right, what about the angle of elevation to the sun if a 6.5-foot tree casts a shadow of 31 feet? So you got a tree, very short tree, casts a shadow of 31 feet. What's the angle of elevation to the sun? So they want that if the tree was 6.5 feet high. It's a baby tree. So what would I do? I'd say, well, I see the right triangle, I think. Yay? So I'm going to use tangent of x. Now 6.5, you may want to just change it to what, 6.5? Now what am I going to do? Right? So I built my equation. What am I going to do now? Use inverse. You guys have like the impossible ability of sitting next to your friend and not talking? Is it impossible? It's like a challenge. Make it a game show right now. You're on Jeopardy. You're trying to beat that guy that's won consecutive times, millions of dollars, and you got to be quiet for 15 minutes. Could you do it?
No.
15 minutes is all you got. Could you do it? Challenge yourself right now. Look at your friend and say, I'm not talking to you for 15 minutes. Don't you look at me. Don't you talk to me. I don't pound you.
See, I don't have
Just pretend you don't speak English. Look at him like no comprende. All right, 11.8 degrees. Does it seem decent? Yeah. It's not going to be big. It's not going to be big, okay? The angle of elevation, again, elevation's with the horizon and then an object above it. Angle of depression is what? With the horizon and then somewhere where I have to look below it. You're going to see some of those. All right, circles. Let's see if you know your theorem. Well, actually, you know what? I'm going to skip. I want to go to this. Got through a lot, but not all. All right, I got to do these. I want to start with this one. So this one came off their released items. I don't know why they're so infatuated with it, but we got to deal with it. AB has endpoints of blank and blank. Point W divides AB into a ratio of 3 to 5. What are the coordinates of point W? So let's draw a pick. So I've got negative 2, 5, and 4, 3 is B. They said there's a W here, and that point divides it into what? A ratio of?
3 to 5.
Max. Where you go? All right, hurry up. Sprint.
It's 4 negative 3
Oh, what is it? Oh,
in
thank
the
you.
B app.
Wouldn't it be funny if like you went to the bathroom, turn off the lights, lock the door, everybody hid? See, Max is pretty good. Well, Max is one of those kids that you can do practical joke. He'd be like, I left the room and then everybody was gone. In my immature days, I would do that. But now I'm mature. All right.
Oh, okay.
Yeah. All right. Dividing it what? W is dividing into a ratio of. All serious aside, we gotta get this one. Ratio of what? 3 to 5. So my trick was to call it 3x, 5x.
Yes.
And then I do it piece by piece. So look at x. From negative 2 to 4, what's that? A distance of 6. So I would say 3x plus 5x is equal to 6. And you're like, why'd they do this to me? This is stupid. 3/4, right? Because if I divide it, I get what? 3/4? Oh God, why'd they do this to us? What a bunch of jerks. All right, so plug it in x. What is that? 3 times 3/4 is 9/4. Now I think I'm going to change that to decimal. I think I'm giving up. 2.25. So what? Yep, this segment is 2.25. So where, I think I've lost some of you. Come on, hang in there, 10 minutes. How far would you go then? Where would you end up? You're trying to find the coordinates of W. 2.25 miles. If you walk 2.25 miles from negative 2, you go past 0 and you end up where? 0.25. You're like, that ain't no point. Well, it is for them. Okay, it is for them. So all I did was from negative 2 to 4, that's a distance of 6. So 3x plus 5x, which is 8x, is 6. So it's a decimal. If you want to change it to 0.75, knock it out. So if it's 0.75, 3 times 0.75 is about 2.25. All right, now let's get y. Maybe it's nicer. I think it is. From 5 to negative 3, how far would you walk? 8. Oh, that is much nicer. So from 5 to negative 3, you would walk 8 miles. So what do I build? 3x plus 5x is 8. So x is 1. And so what is that? Well, what'd you call your segments? Okay, it's 3 times 1, so that's a distance of what? 3? I'll do it in pen. Hope this one writes pretty well. This is 3, so this one would be 5. Are they in a ratio of 3 to 5, obviously? Yeah. All right, so now, how far is 3 from 5? So start walking. 3 from 5. It's not 8, because you're going where? You're going towards negative land. So 3 from 5 would put you at 2. So make sure you look at those. I have those on the EOC problems. They love those. Now, here's the one that's kind of a curveball. This gets you out of your rhythm. We did one of these the other day. When they say, all right, points R, S, and T are collinear, and ST to RT, that's an equal sign, is 3 over 4. You're like, that looks confusing. Point R is located here, S is at NQ, and T is at 8, negative 12. What are the values of N and Q? So I'm going to draw a pick. So R, S, and T are what? Collinear. And the ratio of who? ST to RT is what? 3? Oh, I didn't want that though. I wanted R. Oh, I did it right. Okay. So the ratio of ST to RT. So let's see the curveball. ST to RT is 3 to 4. So I call this guy 3x, and that means the entire piece is 4x. Does that make sense? Because they're in a ratio of 3 to 4. So this to the whole thing is 3 to 4. All right, so if that's true, then what's the little piece? If that's 3x and that's 4x, what's this do? X. All right, now take it piece by piece. From negative to 4 all the way to 8, negative 12. All right, do these first. How far is it from negative 2 to 8? That's a distance of 10. So then I would say, all right, x plus 3x is 10. So each little piece is like, what is it, 2.5? Each little piece is 2.5. So this piece is 2.5, and then this piece would be 3 times 2.5, which would be 7.5. Don't worry about this. So 2.5 from negative 2, that's what you're looking at, would be what? Puts it at 0.5? All right, how about the y's now? Then we're almost done here. From 4 to negative 12, how far would you walk?
16.
So then it would be x plus 3x is equal to 16. So x is 4. All right, so then, now go back here. I'll do it in pen so it looks a little better. So then what did I just find out? That this is 4, so this would be 12. You see I'm breaking this down into pieces. All right, so if that's a distance of 4, 4 from 4 would put me where? 4 from 4, now I'm going towards negative land, so 4 from 4 I would be at 0. All right, definitely think I lost you. It's okay. It's not easy. Hang in there. Is this like a marathon? You guys feel like a marathon?
No.
Oh, I didn't get there.
Oh my. Oh my. Holy crap.
I can't spend too much time on that. All right, let's do one of these jobbies. So,
How many pages is that thing?
I just want to do a couple of one of these things. I don't want to miss it. I don't want to throw away these points. One year I threw away these points and it ticked me off, so I'm not doing it. All right? What am I going to do? I'm going to take the equation of the circle, and then I'm going to translate it x minus 2, y minus 5, and then I'm going to dilate it by this rule. All right? What's that rule say? 3/4 x, 3/4 y. So what we're going to do is I'm going to go wicked fast because we've done a lot of these, right? So first you want to get your x's together, get your y's together, and if whatever's not an x and a y, move it over. All right? What's half of 12?
6.
Square it.
36.
Add 36 to both sides. So that makes the perfect square, x plus 6 squared. Take half of negative 10.
Negative 5.
Square it, 25. So I'm going to add 25 to that. So you got to add 25 to that. So y squared, oh my fault. So that's going to factor to what? Y minus 5 times y minus 5. Sorry about that. And this all equals 64. So I know that the old center is negative 6, what, 5? Because it's positive 6, negative 5. So the old center is negative 6, 5, and it has a radius of 8. Now the new circle is going to get moved. It's getting moved, what is it? See, I don't have a symbol. So that's x plus 2. So if it's x plus 2, it's going to the what, right? So that makes it negative 4 now. And then it's going down 5. So down 5 from 5 will put me where?
0.
Good. Well, watch carefully. Don't let your guard down. If I'm going to dilate this by, what is it, 3/4? And how do I know that? Because it says 3/4 x, 3/4 y. What's 3/4 of 8?
6.
So the new radius is 6. All right, let's see if you can write the equation now. So here's what I did here. I took this equation, found the center of it. Did you guys do that in your Miss Lowe's? I think you guys did, didn't you? Yeah, okay. So I completed the square, take half of 12, 6, square it, add it to both sides. Took half of negative 10, squared it, added to both sides. I got the old center was this, the old radius was 8. Now if I move it over to down 5, there's my new center, right? So I want to hear everybody write this equation. What is it? X
Plus 4.
squared plus,
Y.
since there's, yeah, it's a 0, so you just put what y squared is equal to? 36, right? It's just y squared. Now could you put y minus 0? Yeah. Yeah. All right, prioritize. We still did do a lot. A lot. Probably I'm tired. Yeah, just make sure you know your circle stuff, okay? Make sure you know your central angle's equal to it. Because my daughter did say that there's stuff on there, right? An inscribed angle is half. An angle on the inside is half the sum. So the ones they look like is this. They said, all right, this is x plus 15. This is 2x minus 18. If this is 70, what's x? So what would you say? You'd say this angle's in the center. Not the center. That angle's on the inside. So it's what? The sum of these two arcs divided by 2. Right? It's the sum of 70 plus whatever 2x minus 18 is, divided by 2. Now I would kill the fractions by multiplying by 2. So that's 70 plus 2x minus 18, and then that ends up being 0. All right. So this would have to be a little bit bigger. Let's make it 3x. All right. So I multiply by 2 and then I go forth from there. Now she did say there was one where the angle is on the outside. So if it's on the outside, we do not half the sum, but what? Half the difference. Okay, the difference of those arcs. A minus b over 2. And then yesterday I did one of these. It was real quick, but I had all this stuff. And they ask you a bunch of questions. Oh gosh. And that was the center. I wish I could have done this a little earlier, but it's all right. My dad's a TV repairman. So they'll come up with a bunch of facts, and maybe they say this is 110 degrees. So they start asking you kinds of questions. Select all that apply. All right, here we go. I need another letter here. L. Is AQL half of the arc QL? Is the angle AQL, that's this angle, is this angle half of this arc?
Yes.
Yes, so that's true, because it's an inscribed angle. True dat. Is the measure of AB equal to 110? So it's Bersani that's been talking the whole time. She called him wrong.
Yes, yes it is.
Let's beat the truth.
Actually.
Yes, right, that's true.
Yeah.
Is angle PBN 90 degrees? Is angle PBN 90? Yeah, because this is a tangent, so when the line goes to it, is that a 90-degree angle?
Yes.
Yes. Is the measure of... Yeah, like that. Is the measure of PBM double the size of arc AM? So PBM is this angle. Is this angle twice as big as this arc AM? Oh, you don't know enough because it has to go this way. Never mind. Bad question. Don't like it. It'd have to go all the way over here. And the answer I was trying to get to is no. Remember, the inscribed angle situation, even though it looks kind of funky, this inscribed angle should always be half of the arc it intersects. All right, done. Done, done, done on that part. We're almost... but I would make sure I know all my stuff. Complementary angles are 90, supplementary angles are 180. There may be problems as easy as this stuff. And they'll say, what's x? And you'd say, oh, 30 and 40 are equal. No, they're not. These are vertical angles, and then together, what? Those angles add to 90. They may have situations where you have x, 2x minus 10, and find y. And they may say, all right, first of all, these make a line. So if they put them together, they add to 180. So I'm able to find x, and then once you get x, you'll be able to find all those other guys, all right? But the basics. Don't forget the basics. All right, I like this one. This was released by the state. This will be the last one, I promise. All right, an architect is designing a condominium. A side view of the top building is shown in the diagram. The measure of MNT is 72 degrees, and the measure of QTS down here is 34. If SQ is parallel to MN, what's the measure of QSR? So basically, find x. Now, they didn't draw it, but could I extend that line if I wanted to? The answer is yes. Could I extend this line if I wanted to? Kind of yes. Here's why. And then again, it's like, is this legal? You're not allowed to just let lines keep going. Yeah, you can. You can let lines keep going. They can keep going all the way to the beach. Okay? Now, if that's 102, my fault. That's 72. Is this 72? What kind of angles are those? Corresponding. You're below this parallel line. I'm below this parallel line. So what does the 72 have to do with anything? It's not even inside the triangle, you idiot. Yeah, but this is 108. Right? That's 108 because it makes a line. Now, zoom out. Is this a triangle? Let me go yellow. Is this a triangle?
Yeah.
Yeah, so that's 108, way up there in the corner. That's 34, so that's 142. So that means this is 38. So what's the angle right here? 142. So one more time, here's what I did. I extended the lines. It's okay. So I kept going because how am I going to use the parallel line stuff? Here's a transversal, but how am I going to use it? Well, if that's 72, now that's 72. So if that's 72, that's 108. Now I look at this yellow triangle because I got to use the 34 somehow. So 108 and 34 gives me that. Once I get that, I get that. All right, so study it up. Okay, study it up. Make sure you read all your notes.